class, you are welcome back to my class. We are still on valency. In my past video, we discussed about the valency of the first 10 elements, their chemical symbols, and their shell electronic configuration. So in this video, we are going to look at 11 to 20 elements, their chemical symbols, and their shell electronic configuration. And once you know how to write their shell electronic configuration, you'll be able to write their number of valency easily. So let's start with number 11. So number 11 element is called sodium. So the chemical symbol for sodium is derived from the Latin word natrium. It is derived from the Latin word natrium. So the first two letters is the chemical symbol for sodium, Na. Then followed by magnesium is Mg. Aluminium is Al, the first two letters. Silicon is Si. Phosphorus is P. Sulfur is S. Chlorine is Cl. Argon is Ar. Then potassium is derived from the Latin word kalium. Potassium is derived from the Latin word kalium. So the first letter is the symbol for potassium, K. Then followed by calcium. Calcium is Ca. To write their shell electronic configuration, we are going to apply the knowledge of electron distribution, whereby electrons revolve around the shell. So we have 7 types of electronic shell. We have K, L, M, N, O, P, Q shell. So the first shell is called K shell. The first shell is called K shell. Then circle is an electronic shell in chemistry. So the first shell is K shell. Then the second shell is L shell. The third one is M shell. Then the fourth one is N shell. N shell. So we have K, L, M, N, O, P, Q, so and so on. So the first shell, which is K shell, will not take more than 2 electrons. Will not take more than 2 electrons. The electrons revolve around the electronic shell. So the first shell will not take more than 2 electrons. While L, M, N shell will not take more than maximum number of what? Of 8 electrons. LMN will not take more than 8 electrons. So let's write electronic shell for sodium. Sodium is the number 11. Sodium is the number 11. Then we should not forget that the first shell, which is K shell, will not take more than 2 electrons. So the first shell will take 2 electrons out of 11 electrons, because the atomic number of sodium equal to 11. So therefore, the number of electrons equal to 11. So out of these 11 electrons, the first shell will first take 2 electrons, which is K shell. Then followed by L shell. L will take 8 electrons. So 2 plus 8 will give us 10. So the last electron will be on the third shell, which is M shell. So to write shell electronic configuration, the first shell takes what? 2 electrons, that is 2, comma. Then the second shell takes how many electrons? That is 8. 2, 8. Then comma. Then the third one takes how many electrons? That is 1. So comma 1. So 2, 8, 1. K, L, M shell. So let's move to magnesium. Magnesium is in number 12. Magnesium is in number 12. So the first shell will take 2. Then we should not forget that if you don't complete one shell, you must not move to the next shell. So the first shell will take 2 electrons out of 12. Then the second shell will complete its own 8 electrons. LMN will take the maximum number of 8 electrons. So the second shell will take 8 electrons. while the third shell will take 2 electrons. So the electronic configuration will be the first one 2, then L shell 8 electrons with 8 electrons, and M shell with 2 electrons. So that's 2, 8, 2. So instead of drawing electronic shell in this form, I'm going to use this ratio method for aluminium. So aluminium, the first shell will take 2 out of 13 electrons. So the first shell will take 2. Then the second shell will take 8. Since L will take the maximum number of 8 electrons, 2, 8, then out of 13 electrons, it will remain 3. So 2, 8, 3. So let's move to silicon. The first shell will take 2. K shell will take 2 electrons. L will take 8. So the first shell will take 2. Then out of 14 electrons, then the second shell will take 8. Then 2 plus 8, that is 10. Out of 14, it will remain 4. So that's 2, 8, 4. So 15. The first shell will take 2. Then the second shell will take 8. Then the third will take 5. So followed by 16, number 16, that is sulfur. The first shell will take 2. The second shell will take 8. Then the third shell will take 6. 2 plus 8 plus 6 will give us 16. Then followed by 17, number 17, that is chlorine. The first shell will take 2. The second shell will take 8. Then we should not forget that the first shell will not take more than 8. Then the third shell will take 7. 2 plus 8 plus 7 will give us 17. Then followed by argon. Argon in number 18. So the first shell will take 2. The second will take 8. 2 plus 8, that is 10. So we are going to 18 plus 8. So 2 plus 8 plus 8 will give us 18. Then let's move to potassium. Potassium with 19 electrons. So the first shell will take 2, which is K shell. K will take 2 electrons. Followed by L. L will take 8 electrons. Then followed by M shell. M will take the maximum number of 8 electrons. So M will also complete its own 8. 2 plus 8 plus 8 will give us 18. Then we are going to what? 19. So remaining 1 electron. So it will be 2, 8, 8, 1. So the last one is calcium. So the first shell will take 2. The second will take 8. The third will take 8. 2 plus 8 plus 8. That is what? That is 18. So out of 20 will remain 2 electrons. So this is K, L, M, N shell. So their last electron is called valence electron. Those elements with 1, 2, 3, 4 are positively charged. So the number of their valence electron is the number of their valency. The number of valence electron is the number of their valency. So while those one with 5, 6, 7 are negatively charged. So those ones that completed their outermost shell, those one with complete outermost shell, are neutral. And their number of valency is always equal to 0. So those ones that completed their last shell, their number of valency is always equal to 0. So those ones with 1, 2, 3, 4 are positively charged. So their number of valence electron is their number of valency. So let's start. So this one is the last shell. It has 1 valence electron. So therefore the number of valency will be equal to 1. Because those ones with 1, 2, 3, 4 are positively charged. So this is the last shell for magnesium. It has 2 valence electrons. So therefore the number of valency will be equal to 2. Then followed by aluminium. So this is the last shell. This is the valence electron. Since we have 3 valence electrons, the number of valency will be equal to 3. So followed by silicon. we should not forget that those one with 1, 2, 3, 4 valence electrons are positively charged. So the number of their valence electron is the number of their valency. So this one is having 4 valence electron. So therefore the number of valency will be equal to 4. When it comes to those elements with 5, 6, 7 valence electrons, how are we going to calculate their number of valency? Then we should not forget that the first shell, which is K shell, will not take more than maximum number of 2 electrons. Will not take more than 2 electrons. Then I said that L, M, N shell will take the maximum number of 8 electrons. Now, for this element, the valence electron is 5. Then it needs what? 3 more to complete that what? That M shell, because this is the third shell, KLM. So it needs 3 more electrons to complete that M shell. So therefore, the number of valency will be equal to -3 because it needs 3 more electrons. So let's come to this place. For this one to complete that 8 electrons, it needs 2 more electrons. So the number of valency will be -2. Then those one with 7 electrons, with 7 valence electron, needs 1 more electron to complete their shell. So therefore this one will be -1. It needs 1 more to complete that 8. So the valency equal to -1. So let's look at this one. This one completed that third shell. It completed that third shell, which is M shell. So those one with complete outermost shell are neutral. So the number of their valency is always equal to 0. Now, let's look at this one. It has 1 valence electron. So those elements with 1, 2, 3, 4 valence electrons, so their number of valence electron is their number of valency. So the number of what? Valency for this potassium is 1. So the number of valency for calcium will be what? Will be 2. So we've come to the end of this class. Remember to like, share, and leave